Thank you. So, first off, if I may ask you guys a quick question. Hands up if you're in some way working in security. Okay, almost all of you. Some way in technology. Gentlemen okay, sure. Just getting a feel for for who I'm pitching to here. So I'm going to talk a little bit about security by nature, not nurture, and how I think that relates to both people and technology as a theme. And also talk about some of the new ways that are emerging of building applications cloud natively, which can really dramatically alter the risk profile. So I'm going to start by getting slightly philosophical. I'm not going to pretend to be a philosopher, but I think it's interesting in terms of what it can inform in the way we build programs of work. So John Locke in 1690 around nurture. Was talking about everyone's a blank slate. They're born at birth receptive to the world, and they can be shaped by the way that they're brought up and the experiences they have, and everything about them is learned from their environment. And the competing view put forward by Kant is that actually we're built with sort of native impulses, drives, abilities. We're preordained almost in terms of certain behaviours. So, for a long time they spent sort of 200 years arguing about this before someone realised it was actually a bit of both. Yeah, but still a fun debate. But thinking about that in terms of security, so security awareness of human nature. So if we take that sort of blank slate type approach, then you think people's behaviours, people's beliefs can be shaped through training. That's your traditional security awareness program, that you can almost elevate people. You can teach them about not clicking on links in emails, and that you can succeed in that. And the truth is you can make some progress, but I would hazard that you can't really succeed to the point of stopping any links being clicked on. You can alter people's default behaviour to some extent. You can make them more suspicious of unsolicited emails and things like that, and that's effective, and it does reduce risk. And in some organisational cultures and places, you can achieve real reduction in risk just through that training and awareness. So, for example, I've got young kids. The nursery where they go to, there's a policy. You badge yourself in to the nursery to drop off your kids, pick them up. You never hold the door for anyone. You close it in their face. And at first, it feels horrible. But it's reinforced, and there's the culture there. And over time, everyone gets used to it. Everyone's expecting to have the door shut in their face. And actually, it works. You don't see anyone tailgating through. So you can make some progress there. But then to take the alternate view, there's innate behaviour and drives. Well, you can't fundamentally alter humanity's nature and drives. There are things about us, the need to protect family, a certain amount of jealousy, curiosity. Not only might it be difficult or impossible to train out of people, actually for some of these things there's positive elements, helpfulness and curiosity. You don't really want to be driving that out of your employees, and you can't get rid of that desire to protect your family and loved ones. Frankly, if anyone wants my credentials for my office, then threaten my family. I might have to edit that out. I'll put it on YouTube. But ultimately, I think that's the case for almost everyone. You've got to be pretty psychopathic for that not to be the case, right? So you've got to design systems that take into account the humanity of people and acknowledge that. And, example to counter the tailgating sort of by culture is a turnstile where it's one at a time. And that's putting in place a design that enforces the behaviour, almost to acknowledge that it's too difficult to reliably achieve the culture that would be required to get that behaviour. Now, I'm then going to take a slightly different view, which is, okay, well, thinking about applying that same sort of mindset to technology rather than people. And, you know, how can, if you start with a blank slate sort of model, that's almost how we look at traditional service provisioning, traditional IT. You know, our servers and processes are evolving over a long period of time. You know, we review the access control, we look at the patches, we look at how we securely configure those systems. We run penetration tests and remediation plans, so we're always shaping those servers and improving them over time and developing them much like the blank slate sort of model. You know, we've got the hardware and software life cycle, so, you know, this server's starting to get old, we've got to deal with that. You know, you've got backup and recovery procedures because, you know, if this server we've been caring for forever actually does fall over, we've got to have a continuity plan. We've got to be able to bring another one up and get it back to that same state, and that state has evolved over a long period of time. So that can be a challenge without backups. And of course, ransomware has brought backups to the forefront of many people's thinking recently. You know, and along with that, we have very almost onerous change control processes, monitoring and diagnostics to make sure everything is running and operating as we expect. Now, more recent delivery models for technology are actually moving more towards the nativist model, whereby it's the security and everything about the system is actually innate within the system's design and deployment. So they're designed to be secure out of the box. It's not something that you're going to add in and configure later and keep on top of. You know, you accept that people can and will make mistakes, and therefore you look to eliminate people from as much of the activity as possible. So that, you know, these dependencies, housekeeping and nurturing processes that are historically required, you try and engineer such that you don't have to do those activities. And, you know, you've got to also accept that things are likely to go wrong at some point. So you've got to look at how you engineer things with things like defense in depth, and how to minimize the impact should something go wrong. Likewise, minimizing the attack surface. So what I'm going to talk about a little bit as we go through this talk is really what in sort of modern cloud native applications is actually empowering organizations to build these sort of security native systems versus the more traditional sort of nurtured systems. And quite a useful way of thinking about that you may have heard of is this concept of you know, of pets, that the systems historically that we've built could be considered a bit like pets. You look after them, you tend to them, you feed them, you name them, and you expect them to be around a long time. And if they get sick, you're going to get them to the vets, and you're going to spend money cleaning them up and getting them fixed up and you know, and operated on and what have you. And you know, it requires an awful lot of attention and care and maintenance to keep those pets alive and healthy. And our traditional server estate are pets. We've put a lot of effort into keeping them alive and healthy. The competing view, which a lot of cloud native applications are adopting, is that of cattle, whereby the individual livestock are not named, they're not cared, but they're cared for, but in a general sense. And if one gets very sick, you don't try and, you know, throw any amount of money at that livestock to bring it back to health. Unfortunately, it must go. There's another livestock can be swapped in, and the farm carries on. And you know, it's a very different way of thinking about your technology, and there's companies like Netflix that have taken this to the extreme, and they have something running called a chaos monkey, and the chaos monkey's job is actually to just arbitrarily kill servers within their estate, and the system is designed to be so resilient and to deal with that that's the way they actually cycle their servers. And because everyone who's developing the system knows that this is going to happen, They build the systems to be resilient to it and to carry on operating through this. And that's very empowering. So what I'm going to talk about a little bit now is how we've almost got to where we are now within software, and then how that's now panning out within infrastructure. So, in 1974, Kunigan and Ritchie, in a C programming book, introduced the concept of Hello World. Since then, every computer programmer everywhere, when they've started a new language or a new project, they start with Hello World. In 2011, we've got Andreessen Horowitz saying that software is eating the world. So in the space of 40-odd years, we've gone from Hello World to eating the world. I think that there might be some subliminal message in there somewhere. But it is all conquering, and it's conquering at an unprecedented scale. Software is now ubiquitous in everything, and that's devices around the home, around the business, and so on. And there's cost driving that, but there's also a lot of other things driving that, which I'm going to touch on in a minute. But one thing to just sort of keep in mind is just how cheap it is now. I think it was probably 18 months ago, I bought a little microcontroller module with built-in Wi-Fi antennae, Wi-Fi, chip processing, everything, including postage from China, £1.54. So that's everything you need to do something like a smart toaster, smart kettle, smart fridge, whatever it might be, £1.54. So when it's that cheap, you only have to add a very small amount of added value in terms of functionality that you can sell to your customers to justify that investment, to embed that in. So that's why we're going to see it increasingly everywhere. So what's driving it? So this quote, I think, is really quite telling. Controlling complexity is the essence of computer programming. And it's also the essence of security in many senses. But what's really enabled that is modern languages, modern operating systems and libraries that have really allowed the complexity of a particular bit of functionality to be contained as a black box and then consumed by other parts of the system. Next up, we've got the Unix philosophy: write programs that do one thing and do it well, and write programs to work together. So this is really around the integration of separate specialist programs and libraries and applications in order to achieve a more complex end solution in a way that scales. And that's really this concept of encapsulation, where you've got something that's quite complex, but you put it inside a box and you make it a simple way of operating it. So, in a sense, I guess a taxi driver is perhaps a good analogy, in that learning to drive is quite complicated. There's a lot of things going on. You've got to be coordinating a lot of bits in the car to drive a car. Or you can summon an Uber, you can get in the car and you can say, I need to go to B, and they'll take you. And the latter is encapsulated. It's encapsulated and hidden, the complexity inherent in driving the car. Decoupling is around when you've got parts of your system that if they touch many other parts, then it becomes very fragile to change, because a change of any one of those parts, any dependency, can cause an issue within this particular sort of module or component. So if you can reduce that coupling and make it more self-contained with clearer interfaces, then you can reduce that complexity and dependencies. And then finally, I've got, in open source, we feel strongly that to do something well, you have to get a lot of people involved. I think that's another thing that's really driven this, which is the internet, open source, and Agile has really driven down those cycle times by allowing people to share the work they've done, to build on the work of others much more quickly. It used to be the case that it was, a 5 or 10 year cycle time between someone doing some research, a PhD, writing a book, publishing it, or forming a corporation, working for a few years, building some software, selling it. You're talking really quite a long cycle time. But now on the internet, you'll perhaps have a few people around the world that are working on a particular problem, almost in real time publishing their progress, building on each other's work. And the level of productivity gain within the software community from that is unbelievable. The amount you can achieve with almost no resources now that would have taken man decades even a few years ago. So I think there's a new frontier in abstraction encapsulation, which is applying those same principles that have enabled the software industry to take over the world are actually now being applied to infrastructure and the data center capabilities and components. And that's really what cloud is all about. It's encapsulating, decoupling distributed systems, focusing on particular parts, and then the integration of that. And you know, if we think about what that means in terms of complexity, sort of thinking about a traditional product, you're going to start with a data center. So, you know, in the good old days, any big company would start by buying real estate and physically securing it. You then got to think about how you're going to lay your racks out, your top of rack switches and your cabling and routing and all of these things. You've then got the hardware you're going to put in it, what servers, how long's the life span of these servers, how long are we going to take before we swap them out, are we going to standardize, what different sizes and things are we going to have. You're then thinking about, okay, well, what operating system are we now going to put on that? How are we going to secure that operating system? Where's our secure configuration guide coming from? What users do we have to configure? You're then saying, well, we need to scale up for Cyber Monday. We need to be resilient against XYZ event occurring. You know, we've got to be able to have business continuity and disaster recovery if something goes wrong. How are we going to build all of those things in? It usually means more data centers, more hardware, more racks. You then start worrying about your application development. How are we going to build a secure application on top of all of this stuff that we've had to provision so far? And then finally, you deliver your content or service that you actually sell to your customer. Now, that stack is inherently incredibly complicated. There's lots of parts of that you can get wrong, and things can go awry, and it introduces complexity. So what we've seen is that, you know, the opportunity to differentiate your product that you're selling to your customers is really over here at the content or service you're delivering and the application you're developing, not over here in your data center and your data center infrastructure. And you know, the other aspect is that increasingly the sort of more foundational parts really are commodity. There's not really anything different about your data center versus someone else's data center and so on. So, you know, what we saw was that there was the same sort of process. We started seeing increasing abstraction within the data center. So it started by, well, we'll use a third party's physical data center premises and we'll have our own racks and things in it. We then saw people saying, well, okay, I'll have a dedicated server in someone else's racks and, you know, and switches. And, you know, as you do this, you've got this concept of a shared responsibility model that was sort of introduced a little bit in the Zscaler talk earlier, if you were there, whereby, you know, the part in green is now being delivered by a commodity scale specialist. Your next sort of step from that was your push to virtualization, virtual servers, infrastructure as a service, where the next part is being taken off and provided by the commodity. You then got platform as a service. So at this point, you know, the operating system and all of those bits are all abstracted away from you. Often the scaling and DR part is also part of the platform, sometimes not. The next up, now this is the one that perhaps going to be less familiar to people in the audience. Who's heard of serverless? Okay. So serverless is the next level of abstraction, and really what it's saying is that in order to develop an application, I don't want to be worrying about how I configure and manage individual servers, how I'm going to lock down my operating system, how I'm going to scale it, how I'm going to make sure that my identity of my administrators is managed, and so on. Instead, it's taking the model of sort of compute resources as a service almost, where you say this is the processing that I want to be done, and relying entirely on the platform that's providing the serverless capability to then actually scale and do that process, and it's event triggered. So you might imagine that you've got something like an e-commerce site. Well, when a customer requests a page, traditionally that would get routed through to your web application server, which would then query your database, build a page, and send it back to the user. Under this sort of model, the user comes in and they trigger an event. The event then requires processing, and it goes on a queue. And the platform will actually effectively, in the background, it will start up however many servers it has to process the queue of tasks that are waiting to be done as quickly as possible. And you actually get charged, sort of, for example, on Amazon Lambda functions, which is one of the most mature offerings, you get charged by the 100 milliseconds of processing. So if you imagine that traditionally you would have maybe one server processing a lot of people and they'd all be queued up back to back, and that might take a few seconds to get through a big burst of users. Well, on this model, they actually all run side by side in parallel. Your total compute time might be broadly the same, but it can all happen in parallel. So you can actually get a much better scale, much more easily. And also, because the provider is provisioning the server for your little bit of code to run on, you've not got administrative access to that server that you can get wrong. You've not done the secure configuration on that server that you could get wrong. There's a lot of complexity removed in that way. And then the final sort of step of abstraction is really software as a service. That's taking it to the next step, where really you're only looking at the content or the service that you're trying to sell. That would be white labeling someone else's product. Or the other thing that you see is something called a service full model, where you integrate parts of other people's applications into your application to build your offering. And often those are standalone parts that you're integrating are in many ways a software as a service model that are being integrated. And you know, as you look at this, you know, the sort of the red side, as it were, is really your challenge in terms of execution. Depending where you are on this abstraction hierarchy, depends how much you've got to execute really well on to stay secure. On the green side, you're relying on somebody else to execute really well to stay secure. So, you know, it becomes a question of trust. It becomes a question of, is it actually the case that I could execute this better, at scale than a commodity provider? And I think often the answer is that the commodity provider, through automation, specialists, and scale, can often outperform what we can realistically do on a smaller scale. So, in terms of serverless and what it means for security, I'm going to return to the quotes I used earlier. So, controlling complexity. Complexity means errors. It means increased learning time for getting someone up to speed on a system. And of course, someone who's not up to speed on the complexity of a system are going to be the people who introduce errors in your application design. You get fragility to change. You know, through that complexity, someone will change something expecting it's contained, but actually there's some ripples and knock-on effects which can occur. You end up with a dependency on bureaucracy. You need a lot of change control process, a lot of monitoring, a lot of gates and governance in order to ensure that these fragile systems don't get broken. And that, you know, in turn means you need these sort of strict rules. Now, with regard to the Unix philosophy about this idea of well-contained modules which are specialists and optimized for a particular task, it's really that idea applied in the cloud context for delivering parts of applications that's sort of at the basis for the serverless model. And then the idea of composition through this sort of serviceful model, where you take best-in-breed components within your application and bring them together. So, you know, a good example is something like, I think it's Zendesk, I think it is, will do your customer service and things like that. Well, they have little plug-in modules that you can drop into your web application that can provide real-time chat and customer support and things like that. Now, frankly, you'd have to be a little bit bonkers to build something like that yourself today, when you can put a few lines of code in your application and actually get this best in breed that's been built by experts on those workflows and those capabilities and integrate that in. So, this also feeds to this idea of well-defined, tightly encapsulated microservices. So, who's heard of microservices? Okay, again, not too many. So, I'll explain a little bit on that. It's really taking this idea of encapsulation and small modules to the extreme. So you make it the smallest possible module that performs a useful function. And one example I like to use is imagine you were building a banking aggregator. So people have accounts with a number of different banks, and you want to give them a view into their bank accounts across their credit cards and their current account and so on. Traditionally, you'd have a web application, and that application would have a database with all of the credentials for the bank in, and the web application would query each of those banks, get the information presented back to the user. Thing is, if something goes wrong on that model, then whoever's managed to compromise that application has access to every credential for every account of every user of that service. It's very, very high risk, very, very high impact. If you were to take more of a microservices type approach, what you would do is you'd say, actually, I'm going to have a small module which is very well defined, very well tightly controlled, and the only job of that module is to take people's banking credentials when they enter them and store them securely in a database. Now, that module doesn't even have access to read those credentials back out again. It can only write them in. That's its only job. And that means that if that module is ever compromised, whoever compromised the module might be able to see new credentials going through the system, but they're not going to be able to get all of the existing credentials that are in the system. So you then say, right, so now we have another module, and this other module's only job is to query the bank using these credentials and pull back the transaction information that the users had. And again, that module has no ability to change credentials, but it does have this. That's the bit. That's the crown jewels almost. In that's the part of the system which, if compromised, could compromise bank accounts. So you make it as simple as possible. You control it as tightly as possible, and you decouple it from the rest of the system. So the part of the system that actually builds the portal that the user is going to log into and see the reports on, when that portal needs to get the statements and things, it doesn't go to the database, get the credentials, go to the bank, get the statements and information about transactions. It goes to the microservice that has one job in the world, which is to access the credentials, pull down the transactions data, and pass it back to the application that's going to then display it to the user. Now, by adopting that sort of model, it means that all of the highest risk bits, the most complex bits, actually have no privileged access to carry out transactions, for example. So that's the sort of kind of an example of where you might divide the problem up into very small, well-defined modules or microservices, and then integrate them such that the end user gets a traditional web application experience, but behind the scenes, you've de-risked it significantly because of the reduction in attack surface and the reduction in impact should things go wrong. Okay, I got ahead of myself. So then, looking at Linus is quote, open source really just went, well, you have to get a lot of people involved. People can't be experts in everything. And I think one of the things that this sort of model does is it allows specialization and maturity within a much smaller focus area. Amazon, AWS, is fantastic at provisioning scale storage, and they have world experts in doing that and doing it cheaply. Those are the sorts of experts and resources that I would hazard most of the people in the room could not even attract, let alone afford. And you also get this simplification of priorities through this sort of specialization in doing one thing and doing it well. AWS job zero is security. That's the thing that they worry about before anything else, is how can we do this securely, how can we do it securely at scale, because their entire business is dependent on being able to do that. And with this comes the scale and the automation. They have such a vast estate that they can't do any sort of traditional maintenance regimes. They have to automate it all. And through the automation, they reduce the likelihood of human error, which in turn leads to a more effective deployment of capital, because there's certain costs which are shared amongst all of the customers. You know, if you take something like Amazon S3 storage, sure, if you want to pen test it, but ultimately, you know, Amazon will have paid tens of thousands of pounds to have that one capability penetration tested, and really any amount of penetration testing we paid for in this room would be wasted money. Whereas if we were each building our own object storage engine, we'd each have to be paying for that level of testing and assurance. So there's some great optimization of the utilization of capital and things and expenditure in that model. But it's, you know, there is no silver bullet. It does require more third-party trust, more due diligence, and more risk management in order to make that work. So I'm going to throw up. This is a sort of a traditional application model where you've got lots of different ways of presenting your application across the top, and then you've got the various components that constitute that application, all lumped together in big fat servers within your data center. The sort of new emerging model is to take a very much more compositional approach, where you're consuming third-party services and integrating them into your application in such a way that it's seamless to the end users, but you're no longer responsible for the operation and execution of those individual capabilities. And you've still got certain secrets that you've got to manage from a security point of view, and you've also got the coordination of the various elements that you've got to manage. And that's where this idea of things like Lambda function, the serverless, can really come into play, because they can provide that glue, and they can provide it at scale with minimum attack surface and some, you know, good high level of assurance. So the concerns that frequently come up are, you know, what about vendor lock-in as a result of this? And you know, it's true that the more you consume, the more abstract services, the more you're tied to that particular vendor. But the flip side of that is the cost of abstracting out a vendor entirely is prohibitive in many cases anyway. You know, we'd typically be dependent upon our in-house vendor of some description anyway. And by using this model, we're actually creating so much less proprietary code that the cost of migrating it to an alternative provider is actually probably less than the cost of trying to introduce some sort of abstraction. So personally, I feel that the best total cost of ownership actually comes from going all in and consuming as much of the high level services as possible from these vendors. You know, you've got to take a pragmatic view on it. You've got to understand what they do and where they play and whether they meet your requirements. But in general, the more you can consume, the less you have to do in terms of development. You've still got the risk of implementation errors. You can get the configuration wrong. You can develop an application with application vulnerabilities. These things can still happen, but they could also happen equally on a traditional model. Service availability. This is where the third-party risk management comes in, and also developing applications to be resilient to failure. So there's a couple of things. One is you're dependent on a third party for your service availability. You've got to have the right legal framework in place. You've got to have the right support channels. You've got to understand whether there is something where you can fail over to an alternative provider, what the SLAs are and all these things. Absolutely. But I think it's almost naive to think that we don't have those same things when we deliver the service in-house. We still have to worry about all those same things, even if it's one of our own teams delivering the service. And in some senses, where the vendor's business is at risk if something goes wrong, they're going to be more attentive and more responsive, potentially, than perhaps some more traditional models. In terms of security controls, some of the traditional controls like network monitoring, you know, and your operations and admins actually change quite dramatically on this sort of model. Likewise, things like firewalls. So I'm going to sort of just summarize it here on this with regards to what I see as the advantages, disadvantages, and so on of serverless. The strengths really are around this sort of low total cost of ownership, your scale that you can achieve for really relatively little effort. You've got these opportunities to decompose larger legacy applications into and reduce complexity by doing that, and reduce your attack surface and potential impact as well. But there is, without a doubt, weaknesses and threats. You need this high level of vendor trust and assurance. You need to have a really good third-party due diligence process. You're going to have reduced control, particularly operational control, over those elements that you're buying in. And you need different, expertise. It's not the same mindset. It's not the same way of working. It's not necessarily the same people that are going to be able to do this, which is very difficult to manage. And in terms of threats, there is, it is somewhat fragmented. There isn't standards for a lot of this stuff. Although all of the main cloud providers, one way or another, have a flavour of serverless available. But you need fewer developers and systems integrators. You need fewer developers and more systems integrators. So your job is no longer to code up particular capabilities. It's often to integrate someone else's capability and work out how to glue things together. It's a different type of development, and it's very hard to find and train and retain really good engineers and security engineers, to work in these sorts of environments. It's difficult. I'm going to leave you thinking about this picture and an old story, which is that the definition of a boat. It's a hole in the water that you pour money into. And I think, our traditional technology infrastructure is a traditional boat. We need to keep pouring the money into it to just keep it afloat. We've got to maintain it, and we've got to care for it, we've got to nurture it, and make sure that stays floating. And the moment we stop paying attention to that, it starts rotting away, and eventually it sinks. And we see a big breach. And I think the new way of delivering applications is almost acknowledging how difficult that nurturing process is, and saying, let's get away from that. Let's get away from systems administration. Let's get away from manually configuring for scale, and write applications cloud native so that you don't need to worry about those things. So, thank you.